Hello everyone, my name is Triplus and welcome back to Do-It-Yourself Home Automation and Augmentation. In episode 2 we will be taking a look at the heads-up display. This screen will show me the amount of mails I currently have, the current time, and the status of the commands I recently triggered via Alexa. It will also show me some recent notifications that are interesting to me. The data flow for this project is a little bit harder because my Raspberry Pis are not exposed to the internet. This means we need 3 locations to execute some code. So on if this then that, we need to call a webhook that is located on my dedicated server. Then my dedicated server will send a command to my Raspberry Pi server SSH channels, and then finally my Raspberry Pis will trigger code on my Arduino. The Arduino LCD screen is connected using the following wiring diagram. So there's a controller on the backside of my Arduino which converts the signal to I2C, and then we're able to just connect the power and the ground pins to the Arduino power and ground pins, or the 5V of the Arduino, and then the other 2 cables we're able to connect to pins located on the Arduino. Just using this diagram, you would also be able to use my code that I will upload on my website. Let's start with the Arduino code. So in the Arduino IDE, we are able to write the code that is required to display data on the LCD screen that's connected to the Arduino via the I2C cable management thing. As I already said, I'm not really familiar with all the protocols, but following tutorials usually works. So we need some libraries to include some timer things that I need to keep my current time up to date. We need some LCD libraries to make it easier to write data to the LCD. As you can see, you can just use LCD.print and you just write write what you want. So most of this code is already done. I will also put it on my website. But the last thing we need to do is, once the time is under or the current hour is less than 10. So if hour of the current time is less than 10, we actually want to add an additional 0 in front of the time, because the Raspberry Pi is not smart, or the Arduino is not smart enough to recognize this as time. It just displays an integer. So then we add 10 in front of the current time looper. That's it. So now when I print, or when I push this to the Arduino, which is currently connected to my computer, let's wait for it. Okay, there we go. There's an additional 0 in front, and if I test it now, so let's say I have 5 mails. Let's take the approximate current Unix timestamp. There we go, and then finally type hello world. Let's see what it does. As you can see, 5 mail is currently that time, and hello world. So it seems the Arduino code is completely finished. We can write data to it, and then one nice feature that I spent a while figuring out. So 1 mail, the current timestamp, and then this is a very long line that should scroll. As you can see, this is a very long line, and it's scrolling. The next part now is to create a script on my dedicated server that will be called using webhooks. So the script just uses the SSH tunnel to call my LCD controller Python script that's located on my Raspberry. So then in my webhooks, I can define a new webhook by just simply copy pasting an existing one, changing the name to I think I called it eat a video. Then the script here should be eat a new video.sh. The work directory can stay the same, the secret can stay the same. So if I save this, it should update. Then we call a client to verify if everything is right. Since webhooks just work on HTTP requests, we can simply use this to test if everything is working fine. So if I click send here, the response here is empty, but hopefully if everything works fine, as you can see, it is working. So the screen updated, or the LCD screen updated, and it uploaded a new video. So now the next step is to replicate this behavior in if this then that. So let's go to if this then that. Click on my applets, create a new applet. If on YouTube a new public video from subscriptions with subscriber Ito, and then what we need to happen is call a maker web request. The URL we can simply copy from here. The method is get. The content type is text plain, I think. And in the body we should make sure that the SSH, not the SSH, I mean the token here is using SHA1 to convert this. So I have my secret now as secret, but whatever I type here, we should hash this with the SHA1 protocol and then type it here. So if I create this now, so if new public video from EthosLab, then display notification on screen. Finish. And easy as that, we're able to create one. So I can remove this one now, or at least disable it, because I'm not needing this anymore. I was getting messages on my tablet, but that's not required, as I get them now on my LCD screen. Finally, we have a little Python script running on my Raspberry Pi, which is controlling the LCD screen, or at least the Arduino. So this is just a way, or this part is just a way to use, I think it was called Pickle, to keep the information across sessions, so I don't have to send every data every time. Only the new data I sent will be used to update the screen. Then in the arguments I can pass, for example, mail to get a mail. Then line 1, I tried replacing with the current date and time, as you can see here. Then on line 2 we get the bottom line of the screen, and then we just push everything to the Arduino as we did via the serial monitor earlier in the Arduino IDE, and everything is fine, and we just save the current values in the script or in a little file to keep across sessions. So now we are able to use the Arduino to display data that we want.
Alexa, trigger VPN status.
Sending back to IFT.
Okay, so with that we have finished our first part of the topics I wanted to cover. So right now we have a little LCD screen that is showing me basically what I want to know or need to know, so that's always good. Then in the meantime a lot of parts have arrived, so I got finally my my LED strip over here, which I will try to connect soon. The 12-volt adapter also arrived, so that's nice. We have wires, LEDs, and then some parts, some resistors. This is already something I started playing with, so it's a little LED on a small breadboard, and I will try to incorporate these breadboards into more of my projects because they are very tiny but useful in my opinion. And this is also a little project box right here, which I will try using to put stuff in, obviously. And then I'm also going to try, this is from a big Ferrero Rocher, which I will try to put some LEDs in. Hopefully that works, to use this as a notification ball, depending on the light or the flickering or whatever. So that's also a little project I'm going to tackle soon. And then of course, yeah, the project boxes, my goal is to still create Alexa. Right now it's just a bunch of wires, but I'm going to try to create something small. I'm not sure yet if it will fit in this box, because Pi 0 needs to fit in here together with an Arduino and a screen. So that's going to be difficult, I think, but I'm going to try, measure it out, and we'll see. That's going to be it for today. Thank you guys for watching. Yeah, this episode has been a little bit more technical, which I hope you guys enjoy. Thank you for watching, and I hope to see you guys in the next one. Bye!